Welcome to this class. Today I am continuing the chapter Wave of the subject Science and Technology of class 10, and this chapter is taken in the unit number 10, and we have divided this class into 11 different parts. Out of 11 parts, this is 6th part, and in this part we are going to focus on lens and different terms related to lens. Okay, let's start. What is lens? Do you know what is lens? I think you have seen lens in different sector. In laboratory also probably you have seen lens. Lens can be defined this way. Lens is a portion of transparent refracting medium bounded by two surfaces of which at least one is spherical. The definition seems to be a little heavy. I want to make you very easy the same definition with the help of few points. Look at this. First point, you have to remember that lens is a portion only, a piece only. It is not the big disc like. It is a small portion, just small, not like disc. This is a small portion and it is transparent. Transparent means light passes through it. Light can pass easily through it. This is transparent. Second point you have to remember. And when light passes through the lens, it bends. And bending of light when it passes through a medium is called refraction. We know this, and that's why lens is a portion and it is transparent and it bends light. Refraction takes place in the lens. And another point, it is bounded by two surfaces. From one surface, light enters, from another surface, light comes out. There are two surfaces designed. From one of them, light enters, from another, it comes out. That's why it is bounded by two surfaces. And lastly, you have to remember that out of these two surfaces, one must be spherical. At least one must be spherical, otherwise it wouldn't be lens. If both the surfaces are plane, then it becomes window pane, not a lens. That's why we can say that lens is a portion of transparent refracting medium and it is bounded by two surfaces of which at least one is spherical. This is the definition of lens. Okay, now have a look on different lenses. Look at these lenses. I'm going to present some of the diagram of lens. All these are lens. Yes, it is bounded by two surfaces. From this surface, light is not designed to enter. That's why this surface I am not counting. The light enters from this surface and comes out from another opposite surface, or light can come from this opposite and comes to the first surface. There are two surfaces. Yes, in each of the lens, it is bounded with two surfaces, but one of them should be what? Spherical. Or maybe both the surfaces are spherical. Now let's talk about the type of lens. Different types of lens is seen on the screen, and they are divided into two types. There are two types of lens. One is called convex lens, another is called concave lens. Now I want to show you, look at this. This is convex lens. It is thicker in the middle and thinner at the edge. This is convex lens. And this is thinner in the middle and thicker at the edge. This is concave. Convex, concave. What are they? How to define convex and concave? Let's go through that. What is convex lens? We can define this way. A lens which is thicker in the middle and thinner at the edge is called convex lens. Thicker in the middle. Just remember this. Thicker in the middle. Why don't we have the same diagram? Look at this, is not thicker in the middle. It is thinner in the middle. That's why this is not convex lens. This is thicker in the middle but thinner at the edge. But in the meantime, I want to tell you another matter also. If a lens is seen from front side or back side, it appears somewhat circular, isn't it? Whether it is convex lens or it is concave lens, from front side and back side it appears somewhat circular. But we have to draw diagram of lens through its thickness like this. If we draw diagram through its thickness, then we can see that the middle part is thick or thin. That's why all the time we have to show the lens from its thickness. This is thicker in the middle, that's why this is convex lens. This one, it is thinner in the middle, not thick. So this is not convex lens. I'm going to remove this. Okay. Now this is thicker in the middle. Okay, convex lens. And this is thinner in the middle, that's why not convex lens. This is thicker in the middle and thinner at the edge. That's why these are convex lenses. Among those 6, 3 were what? Concave lens, and these 3 are convex lens. A lens which is thicker in the middle and thinner at the edge is called convex lens. Okay. Now I want to name each of these lenses. All these lenses are convex lens, but they are named differently. How they are named? I want to show this first. This is, let's say, a part of the sphere. A part of the sphere is shown in this diagram. This side is gone inside, and this is called concave surface. And this surface is bulging out, and this is called convex surface. This is a part of the sphere. I want to first make you very clear about the concave and convex surface, and then I'll come back to name these lenses. This is a part of the sphere. This surface is called concave surface, which is gone inside, and this surface is called convex surface, which is bulged a little outward. And with the help of this surface, idea of the surface, we can name these lenses. This convex lens has 2 surfaces, both of them are bulging out, and both the surfaces is convex. That's why this is double convex lens. In this case, this is a convex lens because middle part is thick, but one of the surface is plane, so it is plano-convex lens. This is convex lens because the middle part is thick and edge is thin. But one of the surface is concave, this surface is concave. That's why this is called concavo-convex lens. This way we can differentiate convex lens also into different type: double convex lens, plano-convex lens, concavo-convex lens. There are 3 types of convex lens. Okay. What about concave lens? Let's have concave lens. What is concave lens? A lens which is thinner in the middle and thicker at the edge is called concave lens. Let's have all these diagram again. Among these, this is thinner in the middle, that's why concave. This is thicker in the middle, this is not concave. Okay, this is thinner in the middle, that's why this is concave lens. But this is thicker in the middle, this is not concave. And this is thinner in the middle, thicker at the edge. This is concave lens, but this is thicker in the middle and thinner at the edge. Thicker in the middle, that's why not concave. I selected the concave lens from those 6 different lenses. This is concave lens, this also, this also. Okay, now I want to name each of them with the help of the idea of the surface. Let's say this is a part of the spherical surface, and this side is gone inside. I mean to say this side is somewhat a little inward pushed. This surface is called concave surface, and this surface is bulging out. This is convex surface, as I told you in previous convex lens also. This surface is concave, this surface is convex. Now let's have a look on each of the lenses. Here both the surfaces are concave. Yes, this surface are gone inside, and this surface is also gone inside. These 2 surfaces are concave surface. That's why this is double concave lens. This is also called biconcave lens. But in this case, this is concave lens because the middle part is thin and the edge is thick. This is concave. But one of the surface is plane. Look at this, is plane surface. That's why its name is plano-concave lens. But in this case, this is concave lens because the middle part is thin and edge is thick. This is concave. But one of the surface is convex. Look at this, surface is convex, bulging out. Yeah, and that's why this is called convexo-concave lens. This way, concave lens can also be divided into double concave lens, plano-concave lens, convexo-concave lens. These three are the types of concave lens. Now, after the understanding of the concave and convex lens, we have to go through different terms related to the lens. Different terms. Just for example, if we want to study about this reflection of light or refraction of light, then we must have clear idea about incident ray, reflected ray, refracted ray, angle of incidence, angle of reflection, angle of refraction, normal, etc. These are the terms related to reflection and refraction of light. In the same way, whenever we have to draw the image which is formed by concave lens or convex lens, at that time we have to go through certain terms. So first we must have clear idea about these terms, then we will be comfortable in the study of the convex and concave lens. Let's have those terms. What are these? Number 1, center of curvature. Number 2, principal axis. 3, optical center. 4, principal focus, and usually we say just the focus only. 5th one, focal length. These 5 terms are very important terms which frequently comes while drawing different images formed by concave and convex lens. I want to go through each of them one by one. There is no way we must remember all this. It seems to be a little difficult to remember all this, but you have to remember all this: center of curvature, principal axis, optical center, principal focus, focal length. These are the terms very related to the lens. So let's have each of the term one by one. What is center of curvature? I want to go through a diagram first. This diagrammatic representation represents center of curvature. Here we have C1, I have written here C1, here C2, C3 and C4. They are the center of the glass sphere from which this surface of the lens is formed. We can consider that a convex lens is made by the combination of 2 different pieces of glass sphere this way, and this surface forms by this center, and this surface is formed by this surface, this center. That's why these are called center of curvature. We can define this way: the center of the sphere of the glass, the center of the sphere of the glass by which the surface of the lens is made is called center of curvature. This surface is made by this center, this surface is made by this center. In the same way, concave lens, this surface is made by this center. This way, the center of the sphere of the glass by which the surface of the lens is made is called center of curvature. Okay, let's go to second point. Principal axis. What is it? Again, let's have diagrammatic representation. What is the difference between this diagram and previous diagram? Here we have a line which joins 2 center of curvature. Here, this is principal axis. Principal axis can be considered to be a line which joins the center of curvature of 2 surfaces of the lens. That's why we can say this way: C1, C2, principal axis. It can be defined a line which joins the center of curvature of 2 surfaces of the lens is called principal axis of the lens. This is the normal definition of principal axis. We can extend this line according to the requirement. B1 C2 also, B1 C1 also. We can extend this according to requirement in diagram. Okay, now let's have third point. Optical center. What is it? Let's have a convex lens. This is bisector line which bisect convex lens into 2 equal parts vertically, and this is principal axis. In the same way, let's say this is concave lens and a bisector line divides it into 2 equal halves, and this is principal axis. Now, if we pass light in such a way that it passes through this point, the central point. Then it passes straight without deviation like this. And a ray of light, if passes through this point, whether it comes from up or down, it doesn't make any difference. But if a ray of light passes through this point is the central point. This point is central point of what? Principal axis within the lens. This point is central, and light passes straight through this point. And this point is called optical center, and it is denoted by O. We can define this way. Optical center is a point on the principal axis within the lens. Within the lens, on the principal axis, there is a point through which the ray of light passes without bending. It is denoted by O or C. Normally, we denote it by O. Okay, optical center, very simple, it's understood. Let's have another term, principal focus, which is also called just the focus. What is it? Principal focus or focus? I want to draw again the same. This convex lens, this bisector line, and this is principal axis, this is optical center. And this is concave lens, we have idea about this. This is bisector line and this is principal axis. Now, if the rays of light parallel to the principal axis comes to strike the surface of this convex lens this way, the rays of light are parallel to the principal axis. Then after refraction, what is found? All of them concentrate at a point. All of them converge at a point. But in case of concave lens, the ray of light which are parallel, originally parallel to the principal axis, they do not converge at a point, they diverge, but appears to be diverge from a point of the principal axis. This is that point through which they appears to be diverged. And these points at which the rays of light are converging or from which ray of light is diverging is called focus. This is focus. Now, how to define focus? The principal focus or simply the focus of a lens is the point at which the ray of light originally parallel to the principal axis of the lens pass through. Here, in case of convex lens, they pass through or appear to come from. In case of concave lens, all these ray of light appear to come from this point, appear to come from after refraction by the lens. These points are called focus and it is denoted by capital F. Okay, let's have another term, focal length. What is it? This is a convex lens, this is bisector line. Let's say this is principal axis, the concave lens, bisector line, principal axis. Now, this is optical center of convex lens, this is optical center of concave lens. And the focus lies on both the sides. This is an interesting matter. Look at this. Focus is present in this side also. Why? If light comes from this side, then all the parallel rays of light concentrate at this point, converge at this point. That's why focus appears at right hand side. But instead of this side, if light comes from opposite side, from this right hand side, then all of them converge at this point. That's why focus is present on both the sides. In this case also, focus is present in both the sides. If light rays are coming from this side, they appear to be diverse from this focus. And if light is coming from this side, they appears to be diverse from this focus. That's why focus is present on both the sides. And they are at equidistant. If this focus is at the distance of 2 cm from optical center, the another focus is also at the same distance, 2 cm from optical center. We have to be clear about this. While making diagram, we have to make focus at equidistance in both the sides. Okay. Now, the distance from this optical center to the focus of the lens is actually focal length. It is denoted by small f. In this case also, the distance from optical center to the focus of the lens is called focal length and it is denoted by small f. Have you noticed that we are using both the small f and capital F? Capital F is focus, principal focus, which is also called principal focus, and small f represents what? Focal length. This is a physical quantity, and this focal length, physical quantity, is measured in meter according to SI system. Okay, how to define focal length? Focal length of a lens is the distance between the optical center and the focus of the lens. It is represented by the letter small f. Now, I told you about all these points. I mean to say the special terms used in the study of the lens, 5 different terms I told you. Now, let's change the subject matter. Now, we are talking about why convex lens is converging lens. Convex lens is called converging lens. What is the reason behind this? Now let's have a convex lens. This is convex lens and this is optical center. The rays of light which are parallel to the principal axis, after refraction, they concentrate at a point. They passes through a point, and this point is called focus. And since all the rays of light is converged at a point, so it is a converging lens. Not only the rays of light parallel to the principal axis, if the rays of light coming parallel to each other also passes through the convex lens, then after refraction they converge at a point, not at focus, some other point than that of the focus, but they converge at a point, whether they are parallel to the principal axis or not. It doesn't make any difference. The ray of light which falls on the surface of convex lens, after refraction they converge at a point. That's why this convex lens is called converging lens. Now, let's talk about the same. Convex lens converges the parallel rays of light which falls on its surface to a point after refraction. So, convex lens is called converging lens. What about concave lens? Concave lens is called diverging lens. Why this tag of diverging lens is given to concave lens? The reason is this. Look at this is concave lens, optical center is there. If the rays of light are coming parallel to the principal axis, after refraction, what happens? They disperse and they appears to be coming from a point. This point is focus. Whether these rays of light are parallel to the principal axis or not, maybe like this also, the rays of light are parallel to each other. After refraction, they appears to be coming from a common point, isn't it? That's why this is called diverging lens. They appears to be dispersing from this common point. That's why this is called diverging lens. Concave lens is diverging lens. We can say this way, concave lens diverges the parallel rays of light which falls on its surface from a point lying in front of the lens. So, concave lens is called diverging lens. Let's go to another part. Why a convex lens converges the rays of light? This is a very interesting question. Yeah. Convex lens converges the ray of light, understood, previously described a lot. But why? What is the reason behind this? Let's have a convex lens. This is convex lens. And we can say that a convex lens is made up of prism. Convex lens can be considered to be made by the pieces of prism like this. Have you noticed this? Here we have many prism. This, it seems to be a prism. This one also, the middle part, this, it seems to be glass slab. But these three are prism, actually prism-like. Exactly not prism. They do not have the same surface at 2 ends, but a convex lens can be considered to be made by the combination of small pieces of prism. Now, I want to tell you something related to prism and I'll come back to the same diagram. Look at the board. This is a prism. If light comes to the prism from one of the side, now this is normal and it cannot go straight. It bends towards normal. We know that light is traveling from rarer medium air to denser medium glass. That's why it bends towards normal this way. And when it comes out from this surface, this is again we have normal. Now, light is traveling from denser to rarer medium. That's why it bends away from normal this way. Have you noticed this? What happened here? Light turned towards the base of the prism. Actually, if light enters into a prism and when it comes out after two successive refraction, then it bends towards the base of the prism. We have to take care of this. Light always turns towards the base of the prism when it comes out from the prism. Okay, now let's say this is principal axis. Yes. Now light is coming from this side. The ray of light coming parallel to the principal axis. Now what happens if this is a prism? Then light bends towards its base. Base is turned towards principal axis, downward. That's why the light turns this way, isn't it? And for this prism, base is at the lower side. That's why it turns towards downward. This way it goes. And this case also light turns towards downward. But it seems to be glass slab. And this principal axis can be considered to be normal. And if light passes through this principal axis, I mean to say light passes through the normal, I can give one arrow mark here, then it passes straight without deviation like this. But for these pieces of prism, what happens? The base is turned upward. So, in this case, the light turned towards upward. And this case also light turned towards upward. In this case also this way light passes through this convex lens. If convex lens is considered to be made by the pieces of the prism, each of the prism turns light towards its base and light converges at a point. It can be shortly written like this. A convex lens is considered to be made by the combination of the pieces of prism. Pieces of prisms are combined in such a way that their base is turned towards the principal axis. Since a prism refracts the rays of light towards its base, so the light rays falling on the entire surface of the lens turn towards its principal axis. Hence, it converges the rays of light. This way we can explain certainly. Now, what about concave lens? Why concave lens diverges the rays of light? I want to talk about this also. Let's say this is concave lens. We can say that a concave lens is also made up of by the combination of small prisms, different prisms. Look at this again. It can be considered to be made by the combination of different prisms. But how these prisms are arranged here, it is different. Base is turned towards upward direction, this case, but in the middle we can consider this middle part as glass slab. And in these three cases, base is turned towards downward direction. Let's say this is principal axis and ray of light are coming, and when it strikes, when it passes through this prism, then each of them bend towards base. This bend towards base this way, this bend towards base this way, and that's why I can turn this way, isn't it? But in the middle, I mean to say in the center, what happens? This principal axis, if a ray of light passes through principal axis, it is passing through normal, that's why passes straight without deviation. But in these three cases, bases are turned towards downward direction. That's why light turns towards this direction, downward direction, and all this appears to be coming from a point. So light is dispersed, light is diverged. That's why the concave lens is called diverging lens, and concave lens, the region of diverging of light by a concave lens is this. Okay, it can be certainly expressed like this. A concave lens is considered to be made by the combination of pieces of the prism. Pieces of prisms are combined in such a way that their base is turned away from the principal axis. In this case, just opposite, bases are turned away from the principal axis. Since a prism refracts the ray of light towards its base, so the light rays falling on the entire surface of the lens turns away from its principal axis. Hence, it diverges the rays of light. This way we can answer. Okay, this part is also finished. Now after this, all these discussions, why don't we go through certain questions? I want to present some questions. Look at this question. And you have to evaluate this, whether the saying is true or false. Look at this argument. Meaning of the symbol small f, capital F and O in the lens is focal length, principal focus and optical center respectively. Is it? At this time I don't know. Later when you think about this and you get correct result or incorrect result, then I'll tell you. I don't know now. Just think about this. Now second, convex lens converges only the rays of light which are parallel to the principal axis to a point behind the lens. What do you think? Correct or not? At this time I don't know. Just evaluate this with the help of previous discussion. Now next, one of the surface of plano-concave lens is convex. Is it? I told you about this, but at this time I don't know. Later I'll tell you. 4. One of the surface of the concavo-convex lens is concave and the edge of the lens is thinner. Is it? Okay. Looking at all these arguments, which one is correct, which one is incorrect? I think till now you have decided. If not, have a look. Look at this. Number 1, meaning of the symbol F, small f, capital F and O. Small f means what? Focal length. Yes, it is given here focal length first. And then what comes? After this, principal focus. Capital F is principal focus, yes. And O is optical center respectively. Yes, this argument is correct, isn't it? Small f, focal length, capital F, focus or principal focus, and O is optical center. This argument is correct, isn't it? Okay, now let's have second. Convex lens converges only the rays of light which are parallel to the principal axis to a point behind the lens. What do you think? We discussed about this. I want to show you one picture. The rays of light are not parallel to the principal axis even though they are focused at a point, isn't it? It means this saying is not correct. Convex lens converges only the rays of light which are parallel to the principal axis. No. Convex lens converges all the rays of light which comes parallel to each other after refraction at a point. That's why this argument is not correct. So I'm going to cross it. Next, one of the surface of plano-concave lens is the convex. Plano-concave lens. Why don't we have plano-concave lens? This is plano-concave lens. And what is the question? What is this argument? One of the surface of plano-concave lens is convex. Is it? No. This is concave, this is plane. There is no any convex surface. That's why this argument is also incorrect. So I'm going to cross it. One of the surface of concavo-convex lens is concave and the edge of the lens is thinner. Is it? Let's have concavo-convex lens. This is concavo-convex lens. Why concavo-convex? There is convex lens because middle part is thicker than the edge. Convex lens, but one of the surface is concave, so concavo-convex. Okay, what is the argument? One of the surface of concavo-convex lens is concave. Yes, this surface is concave, one of the surface is concave, is correct. And the edge of the lens is thinner, yeah. Edge of the lens is thinner in both the side. In this case, in two-dimensional picture, both the side, but in three-dimensional picture, at the edge, it is thinner. Clear? This is correct. That's why I want to tick it. Now, after all this, I want to make a short revision what we did today. I told you about the lens. What is lens? Lens is a portion of transparent refracting medium bounded by two surfaces of which at least one is spherical. And then I told you about types of lens. There are two types of lens, convex lens, concave lens. Convex is thicker in the middle, concave is thinner in the middle, isn't it? And different terms related to lens also I described with the help of diagram. What were they? Center of curvature, isn't it? The center of curvature means the center of a sphere with which the surface of the lens is made. And another principal axis, the line which joins two center of curvature of the lens is called principal axis. And optical center is the center of the lens through which light passes straight. And principal focus, what is it? Light coming parallel to the principal axis of a lens either passes through a point of the principal axis or appears to be coming from a point of the principal axis. And these points are called principal focus, focal length. The distance from optical center to the focus of the lens is called focal length. And then converging lens, convex lens is called converging lens. Why? I described a lot. Concave lens is called diverging lens. Why? I described this also. And what is the reason of this converging lens converges the ray of light with the help of this pieces of prism? I described all these. I think the subject matter what I presented today is understood. Now we'll meet in some another class with some another matter. Okay, now I want to stop this class. Thank you.